Alright guys, here's a review that we're going to do. I'm going to handwrite the problems. It talks about the domain and range. So the very first problem on our worksheet, this is from 9E by the way, 9E, we have y equals e to the x. So the first thing we have to realize is we have an asymptote at 0. And then remember, you're going to plug 0 in, you get e to the 0 is 1. And then you have to remember that e to the first is about 2.7. So 1 comma 2.7, so about there. So here's our graph. So our domain of this is negative to positive, or negative to positive infinity. And our range goes from our asymptote being 0, round bracket to infinity. Our second problem is y equals 2 to the x minus 2. So first thing we have to realize, we have an asymptote at 0, which is great. And then let's think about some values we can plug in for x. Okay, if I plug 2 in, I get 2 minus 2, which is 0. 2 to the 0 is 1, so I get 2 comma 1, which is here. And then I could plug maybe 3 in. I get 3 minus 2, which is 1. 2 to the first is 2, so I get 3 comma 2. So here's my graph. So my domain is negative to positive infinity. My range goes from the asymptote, which is 0, to infinity because it's going upward.
But that's what 3069, but that's not what this is. You just have to write the equation. Or what equation would you write?
Our third equation is y equals negative 3 to the x plus 4. So first thing we have to recognize, we have an asymptote at 4. Okay, but then we have to realize what that negative is going to do. That is going to flip it over the asymptote. So let's think about some values that we can plug in. If I plug 0 in, 3 to the 0 is 1, and then negative 1 plus 4 is going to give me 3. So 0 comma 3 is right here. And then if I wanted to, I could plug, say, maybe 1 in. 3 to the first is 3. So then that'd give me negative 3 plus 4, which is 1. So I get 1 comma 1. So again, my domain is going to go from negative to positive infinity. My range is going to go from negative infinity up to the asymptote, rounded bracket at the 4.
Here, not here. They gave you that angle? Oh, you mean that? No. You're trying to figure out what x is. So
Our fourth problem is y equals 2 times 2 to the negative x. Hi, who you looking for?
Mr. Lefebvre.
Yeah.
That's him.
Hey, I was just trying to see if he could possibly help me on my math.
So we're going to plug 0 in.
Geometry?
It's pre-calculus on.
So 2 to the negative 0 is 2 to the 0. 2 to the 0 is 1, so I get 2 times 1.
Oh, Mr. Orsby.
0 comma 2. Oh, we have an asymptote. We have an asymptote of that because we're not adding anything to it. And then maybe if I plug 1 in, 2 to the negative 1 is going to give me half. And then half times 2 is going to give me 1, so I get 1 comma 1. So this problem looks like this. So again, my domain is going to go from negative to positive infinity. My range is going to go from the asymptote of 0 to infinity because it's going upward.
So that's your first thing. What are they giving you? Is that next to or is that across?
So that was 1A through D. Now we're going to get to number 2A. 2A. I guess I'd label those wrong. Equals 1/2 times 5 to the x minus 2. So again, we're not adding or subtracting anything out here, so I have an asymptote at 0, which is fine. I'm going to plug, well, let's plug 2 in. The reason I'm plugging 2 in, that's going to give me to the 0. So I get 5 to the 0 is 1. 1 times half is half. So 2 comma half is about right there. Maybe we'll plug 3 in as well. If I plug 3 in, 3 minus 2 is 1. 5 to the first is 5. 5 times half is 2.5. So 3 comma 2.5. So it looks like that. So my domain goes from negative to positive infinity. My range goes from my asymptote 0 to infinity. Again, those are soft brackets. Oops, went the wrong way. So 2b is y equals negative e to the x plus 3. So first thing you have to recognize, I have an asymptote of positive 3, which is there. So let's plug in some values. So if I go e to the 0, that's 1. 1 plus 3 is 4, so 0, 4, which is right there. Maybe we plug 1 in. E to the first is 2.7. 2 plus 7 plus 3 is going to be 5.7. So 1 comma 5.7. There's my graph. My domain goes from negative to positive infinity. My range goes from the asymptote of 3 to infinity. Again, those are all soft brackets. Let's see, 2c is y equals 2 times 3 to the negative x minus 4. So that minus 4 is going to give me an asymptote down here. Okay, and let's start plugging some values in. So if I plug 0 in, 3 to the negative 0 is the same thing as 3 to the 0, which is 1. 1 times 2 is 2. 2 minus 4 is negative 2. So 0, negative 2 is right here. And then maybe we could let's plug negative 1 in. And the reason I'm going to plug negative 1 in is I get negative for the exponent, so that becomes 3 to the first. 3 to the first is 3. 3 times 2 is 6. 6 minus 4 is 2. So I get negative 1 comma 2. Negative 1 comma 2, which is here. So this is what our graph is going to look like. Our domain will go from negative to positive infinity. My range is going to go from the asymptote of negative 4 soft bracket up to infinity. Now I'm going to start skipping around a little bit because there's an awful lot of graphing ones on here. So paste. I'm going to move down to 3b. That's a little different. Y equals 2 times 1/2. And that's x plus 2. Alright, so let's think of some values that we're going to plug in. We have an asymptote at 0 because we're not adding or subtracting anything to the bases. So if I take negative 2 and plug it in, I get 2. Negative 2 plus 2 is 0. 1/2 to the 0 is 1. 1 times 2 is 2. So I get negative 2, 2. Maybe we could plug in... I'm going to choose negative 3. The reason I'm going to choose negative 3, if I go negative 3, I get 1/2 to the negative 1, which just gives me positive 2. Positive 2 times 2 is 4, so I get negative 3, 4, which is here. So that's what our graph's going to look like. Domain will go from negative to positive infinity. Range is going to go from the asymptote of 0 to infinity, all soft brackets. So that's basically how we do those. Then we get to 4, 5, 6, 7. And we want to know if it's growth or decay. Well, for number 4, we have f of x is equal to 2, 3 over 2 to the x. This value is larger than 1, so this has to be growth. Problem number 5, we have f of x is equal to 5, and then 3/4 raised to the x minus 2. Because our base here is between 0 and 1, this is decay. Doesn't matter what anything else is. Number 6, we're going to get f of x equals 1 over e raised to the 2x. Well, e is 2.7, so that becomes 1 over 2.7. So this right here is going to be a decay. And then number 7, we have f of x is equal to e to the negative x to the negative 3. Power to power means we're going to multiply the exponents, so I get positive 3x. E to the 3x definitely is growth because that would just grow very quickly.
This is a really small number. And the closer we get to 4,
8 through 12 I think you should be fine with.
4.000. That's really, really close.
And then 13 through 19, let's take a look at those. So number 13, you get 3 to e to the second times e to the 0 times 4 to the e to the negative 1 times e to the 6th. Okay, so that's just going to give me 1, so we're not worried about that. So we're going to add here and here, and then so that gives me 2. 2 plus 6 is going, or 1 plus 6 is going to give me e to the 7th. Multiply those, so I get 12 e to the 7th. Number 14, I get 5 2 e to the 3rd to the 2nd. So we're going to distribute this here and here, so that's going to give me 5 times 4 e to the 6th. Multiply 5 and 4 together, so you get 20 e to the 6th. Number 15 is going to be 12 e to the negative 4 over 8 e to the 3rd. Okay, so I can reduce 12 over 8 to, let's see, 4 goes into both, so that goes 3 over 2. This is going to move down, so I get e to the 7th downstairs. Number 16, we have, not 3, sorry about that. We have e to the 3 minus x, 2e to the 3x minus 2 squared. So let's take care of the outside exponent first. That comes in here and here. So I get e to the 3 minus x times 4 e to the 6x minus 4. The 4 is going to come along for the ride. Now I'm going to add the exponent. So I get negative x plus 6x is 5x. 3 minus 4 is negative 1. So there's my answer.
5, 12, 13 is a triple. So you
17.
take the time and memorize those triples. Because that's just you not doing the work I've asked you to do like weeks ago, right? So when you see 5, 12, you did all this work.
So things you have to realize, if it's e by itself, it's going to be e to the first. So I'm going to go negative 3 times 7 is negative 21. E to the 5th, that's e to the 6th. E to the 6th minus 1 is e to the 5th.
And it's going to save you work. It's like you'd rather do all this work than you can memorize.
18, I get 2 to the 9, e to the negative 6 to the 1/2. Okay, remember the 1/2 power is the same thing as the square root. So the square root of 9 is 3. And then I'm going to take half of that, so that's e to the negative 3. 2 times 3 is going to give me 6. This is going to move downstairs, so I get e to the 3rd on bottom. Problem number 19. We have a 3e. Remember, e is e to the 1st over 12 e to the 0. So I'm going to reduce 3 over 12. That's 1 over 4. And then I get e to the 1st. Tug of war, top wins by 1. So that's our answer. Okay. 20 through 24, you're just plugging that directly into your calculator, which is going to take place. 25 through 28, I'm pretty sure you're going to be able to handle those okay. Just realize on 25 through 28, what you want to do is want to know a times b raised to the x plus c. So c is our asymptote every time. And then plug in your x and y value. The best thing to do is find one of those to be 0. Okay, and usually it's the y that you want to take place with 0, but it could be the x as well. Okay, so plug those in and you're just going to solve it as a system. And then we need to remember our growth equation. So a equals p 1 plus r raised to the t. And then if I have a equals p1 minus r raised to the t, so this is growth, this is decay. But then we also modify these equations to look like this: 1p1 minus, or 1 plus r over n raised to the nt, where n is compound, how many times it compounds. Okay. If I have the same equation like this, it's going to be 1 minus r over n raised to the nt. So this one's growth, this one's decay. And then we also had this equation. And this is the continuous growth. Growth and decay. Continuous. Okay? So where you're going to start realizing its growth versus decay is basically that p-value is going to dictate the direction it's going to open. And that's where we're going to go with on those. And that should help you out on this test. So I hope that is a little bit better for y'all. Have a great day, everyone. Take care of one another. Have a great day. Bye-bye. Bye.